everyone, I'm Shanaya here, and in this session I will be talking about linear data structures and mostly about stacks. So without any further ado, let's see what is in here. Let's start off with linear data structures. Data structures can be categorized based on how they are arranged as linear data structures and non-linear data structures. Here we will be looking at linear data structures. Linear data structures are a type of data structure where the data elements are arranged sequentially. That is, each element except for the first and last has a previous and next adjacent. Here is an example for linear data structures, which is arrays, and we can clearly see that all the elements other than the first and last has a predecessor and successor. Some other examples are linked lists, stacks, and queues. Next, let's take a look at types of linear data structures. This is further broken down as static and dynamic data structures. The key difference of these two types of data structures is that in static data structures, the size of the structure is fixed. Therefore, the content of the data structure can be modified without changing the memory space allocated to it, which means the memory is allocated at compile time. On the other hand, in dynamic data structures, the size of the structure is not fixed and can be modified during the operations performed on it. They are designed to facilitate change of data structures in the runtime. Now let's discuss about what a stack is. A stack is a linear data structure that follows the last in first out principle, meaning that the last element added to the stack is the first one to be removed. In other words, insertions and deletions are allowed only at the end, which is the top of the stack. Here we have some real-life examples of a stack of books and a stack of biscuits. Here, if we want to add another book or a biscuit, we have to add it on the top and not anywhere else. Similarly, if we want to remove a book or biscuit, we have to do it from the top. We cannot add or remove any of them from any other position. But it could be a bit confusing, as someone could say that we still can access a book or biscuit from other positions as well. So the best way to understand this concept is to think of these books and biscuits are placed inside a box which fits into its size. If so, we definitely cannot access any other object other. Next, we have stack operations. Stack operations can be broken down as primary operations and secondary operations. And under primary operations, we have the first one, push, which is used to insert an element into the stack, and pop, which is used to remove an element from the top of the stack. Under secondary operations, the first one we have is top or peak, which is used to return the last inserted element that is at the top without removing it. And next we have size, which is used to return the size of the stack, that is the total number of elements present in the stack. And then we have is empty, which is used to indicate whether the stack is empty or not, and is full to indicate whether the stack is full or not. Now let's look at a visual representation of a stack's primary operations, push and pop. Stack as an ADT or abstract data type. The term abstract refers to hiding details, which means we focus on what is done but not how it is done. It is from the user's point of view. So in Stack as an ADT, we are interested in knowing the stack operations and not interested in knowing the implementation details. The last topic for this session is stack implementation. As stacks are abstract data types, they have to be implemented using regular data structures to make it efficient. Such data structures are arrays, linked lists, array list in Java or list in Python, and also it can be implemented by using Java's inbuilt stack class. So this is all for this video, and in the next video I will be talking about stack implementation using arrays in Java. Thank you for watching.